Hello and welcome to Pi Excellence Tutorials. At Pi Excellence Tutorials, we solve tutorial questions. We tutor also students, and that is in mathematical methods, in physics, and also in chemistry. We also solve assignments for students or help our students in solving assignments. So if you're looking for a tutor, make sure you just go in the description box. You're going to find the contact details. And in this video, we are going to solve a rotational or circular motion question. That is a floppy disk in a computer rotates from rest up to an angular speed of 31.4 radian per second in a time of 0.892 seconds. And the first question says, what is the angular acceleration of the disk, assuming the angular acceleration is uniform? Okay, so let's start with that. So first of all, you look at the data that you've been given. Okay, so looking at the data that we have been given the initial angular speed, because we've been told that it is coming from rest. So if an object or whatever is coming from rest, it means the initial speed is zero because it was not moving. The momentum was zero. So what we have 0 meter per second. And then we have the final angular speed, that is 31. Oh, sorry, we are not using meter per second here. Okay, sorry. We have radians, right? So 0 rad per second. And this will be 31.4 rad per second. And the time we have is 0.892. So this is the time that it took for this disk to attain that angular speed of 31.4 starting from rest. So what is the angular acceleration? Now we know that the angular acceleration is basically the change in angular speed with respect to time. So what we have is the change in angular speed with respect to time. So the final is 31.4 rad per second minus 0 rad per second over time, which is 0.892 seconds. So angular acceleration is going to be it's going to be 35.2 rad per square second. So you make sure you don't even forget the SI units. And they are very important. The SI units are very important. Okay, then you are done with question A. You go to question B. Says how many rotations does the disk make while coming up to speed? Okay, so when we're talking of rotations, we are talking of revolutions, right? So here what we are trying to find is the angular displacement, in other words. Okay, so we're trying to find the angular displacement. Now, looking at the data that we have a good number of equations that we can use. We have a set of equations that we can use, I think 2 or so, that we can use to find the angular displacement here. So we can use even this one, angular displacement plus half squared. Okay, so because we have the angular acceleration here, so initial angular speed is 0 rad per second times time, which is 0.892 seconds, plus half. Angular acceleration we found to be 35.2 rad per square second, and we multiply by the time squared, that is 0.892 seconds squared. So this part, first part, is going to give us a 0, because when we multiply anything by 0, we get 0. So the other side is going to give us so it's giving us 14. 14. So that would be what? That's percent, so that would be 14 rads. So, because we're talking of rotations, we can convert this to revolutions. So how do we convert this? We have 14 rads, and then we multiply by, we know that 1 revolution is equal to 2 pi rad. Okay, so that will give us the rotation in revolutions. So what we're going to have is 2.2 revolutions. So that's how we find that one. Okay, and then we also go to the C. It says if the radius of the disk is 4.45 centimeter, find the final linear speed of a microbe riding on the rim of the disk. Okay, so now here we remember the relationship. We have to remember the relationship between the linear motion and the angular motion, or sorry, and rotational motion. Okay, so what is the relationship? Because there we have the radius. Okay, so let me write C from this side. So we have been given the radius to be 4.45 centimeter. So the first thing that you have to remember, you can also convert, you always convert the units to standard units. So we know that this has to be in meters. So it's going to be 4.45 percent is baht meters. And then we know that linear velocity is basically a radius times the angular speed. So now what is we've been taught to say, find the final linear speed of the microbe. So we get the final angular speed, which we have been given to be 31.4 radian per second. And then we multiply it by the radius. So we're going to have 4.45 by 10 to the power negative 2 meters. We multiply by 31.4. Yeah, 31.4 rad per second. That will give us the linear velocity. So the linear speed is 1.39, okay, 3973 meter per second, which we can just round off to 1.4 meter per second. Okay. So have found that one. And so that is how you get that. And also, D says, what is the tangential acceleration of the microbe at this time? Tangential acceleration. Well, we also still remember the relationship of which we know that tangential acceleration is given by radius times angular acceleration. We have already found the angular acceleration, and we have the radius. Radius is 4.45 by 10 to the power negative 2 meters, multiplying by the angular acceleration, which is the 5.2 radian per square second. So that will give us the tangential acceleration. So what do we have? What we have is 5.2. So we have 1.5664 meter per square second. That can run it off to 10. So that is how we find that question. Okay, see you in the next video.